Hello everyone, my name is Andran Alin, the Badoka Prophet. I hope you guys are doing very well. And today we're going to be working on a very interesting topic in the field of atomic spectroscopy, talking about what we call the RUSSELL Saunders coupling. Now, this area in chemistry is a very sensitive area in the sense that it will usher us to the field of quantum chemistry. Now, when you look at right on the board, what we call the RUSSELL Saunders coupling, from the word coupling, it basically involves the coupling of angular momenta of atomic orbitals. Talking about the L and L coupling, which will give rise to what we call the L, the coupling of two electrons of the X coupling, and lastly the LX coupling, which will give rise to what we call the symbol J. Now, everything here all boiled around to call the RUSSELL Saunders coupling, and it is a very easy area in the field of chemistry. Now, before we move ahead to some common questions that can be found in exams, we should understand what we call the atomic 10 symbol. Now, the atomic 10 symbol is giving the general formula to what you are seeing here, in which this X you are seeing here can also signify the L, in which it means what we call the total orbital angular momentum. Take note, the total orbital angular momentum. While this superscript here, which is the 2x plus 1, denote the multiplicity of states. Take note, because without your knowledge of this atomic 10 symbol, it will be very difficult to understand some of the foundation to what we call the atomic spectroscopy. Now, we should understand that this subscript here, which is J, signifies or stands for the resultant angular momentum. Do not forget, I repeat, resultant angular momentum. Now, this is how it is. Now, we should understand that basically, when we have the word quantum number from elementary state, we should understand that we have basically 4 quantum numbers, which are the principal quantum number, the azimuthal or the subsidiary quantum number, the spin quantum number, then what we call the magnetic quantum number. Now, all of these 10 will be necessary in this particular area. Talking about what we call the RUSSELL Saunders coupling. Take note, there's something I just want you to understand, that this particular topic and its calculations are very, very simple. So I will be taking my time to see how I can break it down. Now we move to a question. The question says, determine the value of L, which is this coupling now, this RUSSELL Saunders interaction of L, for the interaction between a p electron, take note, a p electron and a d electron. Now, this will forget. Do not forget that under the orbital angular momentum, there's what we call the x orbital, the p orbital, the d orbital, and the f orbital. Take note, in which the azimuthal quantum number for x is 0. For p is 1, for d is 2, and for f is what now? Is 3. Just so you understand. So that when we enter the question, you just follow suit and know that it is not difficult at all. So we move swiftly to the calculation. So solution. Now, in the solution, they said determine the value of L for the interaction between a p electron. Now, knowing fully well, the first of all, the formula should be dropped here on the board. that the formula for the L and L coupling interaction is simple. This L is equal to L1 plus L2, comma, L1 plus L2, you start from -1, L1 plus L2 minus 2, then L1 plus L2 minus 3, so on and so forth. Then lastly is the L1 minus L2. Now, oftentimes we advise students, while you are doing calculations under this RUSSELL Saunders L coupling or interaction, you will start from it is here will be your guide. Meaning it is where this one ends, that is where this one too will also end. Just so you don't make any single mistakes. You start from here. Now we move. Now we should understand now here that okay, so we can clean here now, so we can move ahead in making it much more elaborate. Much more elaborate. So you can see it. Now that we have this formula right here on the board, now we know that there is between a p electron and for a p electron, you should understand that the L for p electron, which is what the L1, which is this L1 here, that which is x is 0, p is 1, so L is 1. While for a d electron, of course, for the L2 here, it will be 2. For you who still not understand this one, remember the x for x it is 0, which is the azimuth. For p it is 1. For d it is 2. For f it is 1 and 3. So follow suit here. Now we continue here in solving this question in an appropriate dimension, so that if I come here, now that I have 1 to 2 now, L1 is 1 and my L2 is 2, so I come here to now say 2, which is okay, which is 1 minus 2. Now remember that this modulus you are seeing here, so if I'm having 2 minus 1 to give me 1, so I'm having 1 minus 2 to give me minus 1. But if I'm not having modulus 1 minus 2, it will give me 1. Because the minus 1 will be removed. So here now 1 minus 2 will give me what now? Will give me 1. So it means it is when it ends in 1, that is where I will what now? I will stop. So I come here. 1 plus 2, comma 1 plus 2 minus 1. That will give me 3. That will give me 2. So 1 plus 2 minus 2. That will give me, finally, that will give me 1. Now, I would have continued, but because this last one here have given me 1, which will be my checkup, so I have to stop here. So it therefore means that my L, when it was 3, it was for the F, the orbital F from here. When it was 2, it was D. And when it was 1, it was P. That is my final answer for this first question. So we'll move straightway to the next question. Very simple.